Alright, downloading and acquiring the shield schematics. Down here at step 2, create shield. Go to this Google Doc. Make sure you hit file download. Make sure you open it with Adobe Acrobat Reader or Pro. You will most likely have to download Acrobat Reader if you do not have it. When you go to print it, choose your printer and make sure that there is no page scaling, none. Alright, go ahead and hit OK. And that's how you print, so it is the correct scale to build. Alright, move on to the next video. Now all you do is have to print out, tape, and drill holes in all the little dots with a very fine drill. Alright, once you have all your holes cut, basically take some steel wool and scrub the copper on both sides. Now what I'm going to be doing is taking this and tracing it on here with Sharpie marker by connecting the dots. Now this does take a little bit of an artistic skill, no doubt about it. I'm going to be doing that for both sides because sometimes you have your headers that work better on your other side to be soldering too. Okay, so I'll show you what that means here. Just trace it or draw it from the diagram here to here by connecting the dots. And what I usually do is just flip this over on a light table or a lit area, flip this over and draw the same leads on the other side. Alright, so I'll show you what that looks like here after I get done tracing it. Also, very important to point out not to touch the copper as much as you can while you're drawing out the lines with the Sharpie marker, because anytime that you touch the copper in that area, it will have a hard time etching in that area. Okay, so just a little tip before you start drawing. Alright, so this is what it looks like completed. So all I had done is taken a Sharpie marker again and went over the dots to connect the ones that are important, and on the other side it is the exact same thing but in reverse, so it looks like that. Okay, again, all you do is have to take your initial print out and put it on a lighted surface, and you can get the best of both worlds, so you can trace from that. So some hand drawing involved, but that's a pretty easy way to make a circuit board. Also know that just because there's an area without a line, I always put a dot there anyway. That way I have an area to solder to. Case in point, these little header pins right here, I'll just put a dot on each hole of Sharpie to protect some of the copper, so I have something to solder to. Then what you're going to do, again, don't try to touch the copper surface too much. Look for an ugly or whatever glass something to stick this in. Reason glass. Well, I can set this over a furnace vent and heat the bottom of it, and it will greatly speed up the enchanting process. So all you're going to be doing is opening the enchanted liquid, fill this with a small layer of enchanting liquid, enough to cover over the board, and then you can leave it for a while, or you can heat the surface of the glass with, you know, something really low. Hair dryer even works. I've sat mine on my printing bed before and it works out really well. All how you do it is up to you. Do not heat the glass any hotter than what is recommended for that type. In other words, don't stick this in the oven, probably would not be a good idea, and do not put it over open flame, another bad idea, unless it's that type of glass that can handle over the flame. Another small warning, when heating PCB enchanted solution, do not breathe in any fumes that might occur if you get it too hot. Those fumes are very, very bad for you. Very, very bad for you. Could cause you to pass out if you're not careful. So, some tips, and I'm just going to fill this with liquid, throw that board in there, and then when it's done, I need to run it under water. Okay? You'll know it's done because the paths will be intact and all the other copper will be eaten off the surface of the board. Alright, so that's my next step in the process of making the PCB. Alright, using steel wool, I basically cleaned off all the extra Sharpie marker, and that made it easy to solder too. So I haven't soldered anything. What I was going to show you is once in a while with this method you might get cuts in the trace. So every once in a while you should go like this, find yourself a good multimeter that measures conductivity, and then put it on conductivity. You can go like this and it beeps. So just go through and, you know, generally kind of test your leads. Make sure you're getting a good beep every once in a while. Now this is not through hole board. In other words, you will have to solder both the top and the bottom. In other words, if it's soldered here at the top, the bottom traces will not receive the same pin because it's not a through hole board. So you're going to have to solder both the top and the bottom if you want that to happen. But here's all the elements arranged. I haven't put the pull-up resistors, but here's all the switches. And then I have this bar. This is my main header. I'm using a 6 header because one of the pins doesn't technically even hook up, so I'd rather use a 6 than an 8. They don't make a 7. I'm going to run jumper wires across these, and my pull-up resistor goes from here to here on all these pins. Alright, so I'm just going to start soldering this up and meet you in the next video. Alright, once you have it fully assembled, it looks like this. Okay, so my sensor can come out and I can use it for other projects. I'm going to incorporate that into the printed design too. You can see the bottom of the shield. Top of the shield. And everything fits in there quite nicely. Now, it's time to program it, which is by far one of the most adventurous things. You're going to need a PC. That's all there is to it. You could do it on a Mac, but I'm going to be showing you how to do it on a PC. So let's jump into programming this thing so it works.